Assalamualaikum warahmatullahi wabarakatuh. My name is Fauzan Bifaruddin, and today me and my group will be presenting about our work and result regarding our latest assignment, which is regarding pulse code modulation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Azad bin Kamaluddin. Today I would like to present example 1. Okay, first of all, equals all. Then we set t equal to 0, 0.01 to 3. A equal to sine times 2 pi t. Next, p equal to square 2 pi 10 2 times pi times 10t. So for figure 1, for label x we put times, label y we put amplitude. So the title is analog signal. Next, second for second subplot is the title is sample signal, which is n equal to 3, y equal to u encode, and r equal to u decode. For figure 2, we need to put the title is encode signal. In figure 2, second subplot and the title is decode signal. Similarly, for figure 3, title is code signal. So we need to run. So we can see this is for figure 1. The above the output is analog signal and the below is sample signal. You can see that the amplitude is 1. For figure 2, for the above output is encode signal and the below is decode signal. And lastly, for figure 3, there is a square signal. For exercise B, so we set the time is 0.5 to 0.0005 and to 1. For x equal to sin c 2 pi t. For c equal to command x 25 and 1 for mu compressor. So next is e equal to u encode. This c 16 is for 16 bit. And next is t equal to u decode. E 16 is 16 bit. And next 0 equal to command b 255 1 and mu expander. So for figure 1, need to plot x is red, plot O which is black. So D1 and D1 we use the same bits, which is 16 bit. For E1 we use encode and D1 we use decode. For figure 2, we need to plot x equal to red and D1 equal to green. So this is the output. So we can see that the figure 1 output and this is the figure 2 output. Next, for simulating example 1, we need to put signal generator, pulse generator, dot product, uniform encoder, uniform decoder, and 4 scope. First, signal generator we must change the unit to hertz. For pulse generator, the period we need to put 1/10 and the pulse width is 5. For uniform encoder, we need to change the bit to 3. Same goes to uniform decoder, the bit is 3. Then we run. For this scope is for analog signal and sample signal. So you can see the output is in same with the MATLAB. For the yellow is analog signal and for the blue is sample signal. For scope 2 is for square wave. So we can see that the output is the same with example 1 using MATLAB. For scope 3 is for uniform encoder. This is the output. And lastly is for uniform decoder. And this is the output. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Today I will show you how to generate PCM signal using MATLAB. Okay, first of all, we type in for the time and message signal, and then we compress the signal using mu law, one way of quantizing, using compan, which is the source code, mu law or A law compressor or expander. So the value used for mu here is 255, and 1 represents the maximum value of message signal. Okay, after quantizing, we encode the signal using UEN code and then decode the signal using UDE code. Next, we expand the received signal using compan again. Alright, next, to plot the graph, we have two figures, which is figure 1, which is PCM with compending, and the second figure, which is PCM without compending. And then I run this program, we get two figures. So the first figure is the original signal, and the received signal using compending. Second figure is the original signal and the received signal without compending.
Now I'm gonna show you how to construct the Simulink connection for received signal with compending and without compending. We start with received signal without compending. We need the signal generator, uniform encoder, uniform decoder, and also a scope. Change the input ports of scope from 1 to 2. Then connect all of the blocks. Then for received signal with compending, we need to have the same as received signal without compending blocks, but with additional of 2 more blocks, which is mu law compressor and mu law extender. Then we just need to connect all the blocks as usual. Set both of the signal generator units to Hz and change the bits of both uniform encoder and uniform decoder to 3 bits. Then click run, and here is the output of sine wave of 3 bits. For without compending, received signal is on the left, and with compending, received signal on the right. Based from the question, we need to change the frequency of both signal generator to 2 kHz and set to 8 bits for uniform encoder and uniform decoder. Then we need to change the time base to 0.01 and click the run. So here's the result. On the left is signal without compending and right is the signal with compending. Then we need to change from 8 bits to 16 bit for both connection, and the output for signal without compending is on the left while signal with compending is on the right.
So based on the results, we can observe that PCM is a type of digital to analog conversion. PCM message signal is achieved by representing signals in both discrete form in time and amplitude. PCM output is obtained by sampling, quantizing, and finally encoding. In the process of quantizing, a sample of analog waveform value will substitute by closest value to 1 code works. Hence, it is easier to generate the signal processing. As a conclusion for this PCM assignment, we were able to understand, observe, generate, and also plot one of the digital modulation techniques where the message signal is represented by sequence of the coded pops. We are able to also to know the advantages and disadvantages of the PCM. Since it is more convenient for long distance communication, it is commonly used in the space communication. So that's all. Thank you for watching.